Welcome to my video blog Questions of Doubt in Corporate Valuation. My name is Bernhard Schwetzler, and our today's question of doubt is it a good idea to apply fade rates or fade factors upon the growth rate in the terminal value calculation? The reason for this idea to apply fade rates is that many practitioners feel uncomfortable by the standard assumption in the terminal value calculus, that is, that the growth rate assumed is to stay constant to infinity. Yeah? And this is the reason why researchers and of course practitioners alike have been looking for ways to limit the growth of the company and to limit the growth of the cash flows, and by doing so, of course, the size of the company as well. Yeah? So the math behind this idea of fade rates and fade factors is compellingly simple. Yeah? It is simply to apply a certain negative growth factor upon the growth rate itself and let the growth decline by a constant rate in every period. Yeah? So you see here that the growth rate in t plus 1 is equal to the growth rate in t times 1 minus this negative fade factor. Yeah? So in that sense, this fade factor is the change, the rate of change of our growth rate from year to year. Yeah? So the result of this assumption is then that our free cash flows grow at a decreasing rate and that our free cash flow is converging towards a certain level, towards a certain plateau level of the free cash flows. Yeah? So here's a simple example. We let our free cash flow grow in the first year at 3% from 80 to 82.4 million. And then we assume that our growth rate is declining at a constant rate of 50%. That is, it is cut by half every year. Yeah? So from 2 to 3, our free cash flow just grows by 1.5%, and then from 3 to 4, it is growing just by 0.5%. Yeah? So graphically, you see the result here that our free cash flow is growing but at a declining rate, and the growth rate is converging towards 0, and our free cash flow is growing towards a certain plateau level, which is around 85 here in this particular case. Yeah? So on first glance, this looks as being a good idea. Unfortunately, on second glance, it appears that this is unfortunately not the case. Yeah? And in order to show that this idea yields some flaws in the calculations and some inconsistencies, we decompose the growth rate again according to our Gordon-Shapiro or value driver model into the two components: retention rate times RONIC is equal to growth. And here you can see by applying this simple decomposition that if the growth rate is not about to stay constant, then either the retention rate cannot stay constant, or the RONIC cannot stay constant, or the combination or both cannot stay constant at the same time. Yeah? So, and now we shall look at the implications of this result. Yeah? By first looking here at the case that the decline in the growth rate is caused by a decline in the rate of return at a constant retention rate, and then in the second step to assume the opposite, that the decline in growth is caused by a combination of a constant rate of return and a changing retention rate, and I will show that in both results we will end up with serious flaws in our terminal value calculus. So the first thing is that we set up our full terminal value calculation model. Yeah? Not just looking at the free cash flow, but of course taking NOPAT, retention rate into account. Yeah? So we start up with a NOPAT of 100, a retention rate of 20%, absolute retention is 20, that yields a free cash flow of 80, and in the first year everything is growing by 3%. Yeah? Our free cash flow is growing by 3%, our NOPAT is growing by 3%, and that yields, if combined 3% growth with 20% retention, yields a RONIC of 15%. Yeah? And now in the second year, here from 2 to 3, the growth rate of our free cash flow declines by half from from 3% to 1.5%. And that means that, of course, at a constant retention rate, that our RONIC has to decline by 50% as well. So our RONIC drops from 15% by half to 7.5%. If we now combine 20% retention rate with 7.5% RONIC, that yields a growth of our NOPAT, and of course at a constant retention rate of our free cash flow as well, only of 1.5%. Yeah? If you would go one step further, then of course the RONIC again must be declining by 50%. So, and that of course yields some obvious flaws and some obvious problems in our terminal value calculation model. Because at some point in time, RONIC, if it declines, must drop below the benchmark of the WACC. Yeah? So the WACC is the cost of capital. And if the RONIC drops below the WACC, that means that the investment that is then taken and financed out of this retained money is not earning its cost of capital and is value destructive. So if we would have had a WACC of 10%, then obviously these 20.6 just earning 7.5 is destroying value, this additional investment, because the cost of capital is 10%. Yeah? So, and of course, that yields the result that if we assume this to happen, we significantly underestimate the value of our corporation, because we do value destructive investment opportunities and realize value destructive investment opportunities with our retained amount of money. And of course, rational investors would not invest under these conditions and would cash out these 20.6 instead of investing it into below zero net present values. Yeah? So this is the first version, and we have shown that the first version is yielding significant flaws and inconsistencies in our valuation model. The second way to look at this is the other way around. We assume that the RONIC stays constant and the decline of our growth rate is caused by a change in the retention rate. Yeah? So again, we look at our full terminal value calculus here. In the first period, nothing changes. Here in the second period, we still earn by definition 15%. So our NOPAT is still growing by 3% from 100 to 103. And in the first year, our free cash flow is also growing by 3%. But then in the third year, the two NOPAT on the one hand and the free cash flow on the other start to grow at different rates. Yeah? Because if we assume our RONIC to stay at 15%, then these 20.6 also earn 15%, and that means that our NOPAT growth must stay constant at 3%. So our NOPAT grows by another 3% from 103 to 106.09. Whereas by assumption, the free cash flow growth starts to decline now from here to here. It just grows by 1.5%. Yeah? So, and of course, the gap between the constant growth of 3% and the absolute NOPAT and our free cash flow growing at a smaller and smaller rate is starting to widen. Yeah? And that yields the result that our retention rate is even increasing. Here it increases from 20% to 21.17. Here it increases further to 22.89. And that yields the result that the money is somehow disappearing. Yeah? So in that sense, we still earn 15% and our NOPAT is growing at 3%, but due to some miracle, our free cash flow is just growing at lower and lower rates. Yeah? And that means that the retention, first, of course, in absolute terms, and second, in percent must increase over time. And that is somehow weird because it means that we hoard some money as the retention becomes higher and higher, and this additional money does not give us any benefit. Yeah? So in that sense, our free cash flow is just growing at a significantly lower rate. Yeah? And that means that we simply assume that we somehow burn the money, yeah, the gap between the increasing gap between NOPAT and free cash flow, yeah, because at some point in time, our free cash flow will not grow anymore, perhaps after 10 or 15 years, whereas still our NOPAT is growing, and that means that we somehow burn the money. It will disappear somewhere. And this is, of course, not very reasonable as an assumption. So the second option also yields flawed calculations and inconsistent valuation models. Yeah? So we now have assumed and we have shown, hopefully, that applying simple fade rates on the growth rates yields serious flaws in the valuation model, yeah? In both cases. Yeah? It either assumes that we burn money by realizing investment opportunities that do not earn their cost of capital, or in the second option, we assume that the money somehow disappears. Yeah? So a possible improvement of the model is to apply the fade rates not directly on our growth rates, but on one of the two components of the growth rates according to the value driver model, either to the rates of return or better to the excess rates of return. So we let, in that sense, the rate of return fade against the WACC. Or we may also apply fade rates on the absolute amount of the invested capital or on the operating assets, or on the combination of both. Yeah? So in one of the next QoD sessions, I will show you how we can implement these two or a combination of these two into a consistent valuation model that captures the terminal value calculation. That's it for today.